Drones, UAVs, aerial robots, quadcopters. What's up everyone? Hope you're doing well. Come for the drones and stay for what exactly is a drone. Today we're going to look into all the different categories of drones and different types of drones and what's the purpose of drones and so on. So let's get started. Hi, I'm Karthik Rangarajan, founder and CEO of Agam Robotics. Today we are going to look into these topics on what's the definition of drone and different types. That's not a typo error, that's like different types of drones. And then we'll look into a specific category of types of drones. And then what are the different parts of a typical drone. And there are like different applications, like purposes, the usage of drones. And what we at Agam Robotics are working on and why we are working on. So before we move on to it, I would want you to fill out this form. It's a Google survey. So if anyone is interested in owning a drone or like owns a drone or wants to purchase in the upcoming months, I would require you to like fill out this form. It takes like a few minutes. It has like basic questions on your requirements. There's like not mandatory to enter your email ID. We don't spam you. So if you are really interested into getting more onto this, I would recommend you to like sign up. If not, you could just like fill out the form and you should be good to go. Thank you. Let's get started. So what exactly is the definition of a drone? A king bee in a beehive, which does not do any work, is actually a drone. But that's not what we are looking for. We are looking at the term drone in the aircraft term. A drone is an aircraft without a pilot or any person on board. That's why the name Unmanned Aerial Vehicle, UAV, unmanned. That's exactly what the definition of a drone is. It can be controlled by a human on the ground, and there's a communication system established between the drone and the pilot, and the signals and communication is sent from the pilot to the drone, or it could be completely autonomous or semi-autonomous. And there's also a term called aerial robots. Since these drones are also considered like robot, and it's in the air, so you get the idea that it's called aerial robot. The same way there are like underground unmanned ground vehicle, unmanned underwater vehicle, and so on. UUV, UGV, and UAVs. And there's another term called multi-rotors. We'll like get into the exact definition, but as the name says, there are multiple rotors in the drone. So a typical drone could have like 2, 3, 4, 5, so on. And specifically in the multi-rotor subset, there is one more term called as quadcopters. Quad means 4, so you get the idea. There's like 4 rotors in the drone, or you can also call it quad rotors or quadcopters. So which one exactly would you use in these multiple different terms? Drones specifically were named for the military activities, like the aircrafts in military used, which are like unmanned aerial vehicle. So those were called drones. But now we are like beyond correcting that definition. The drones, what you see in the events, like, the aerial photography and videography, it's mostly the quadcopters or quad rotors. It's not actually a drone, but it's the name has been stuck with it. So now like any aircraft which is in the air is like a drone now, because it's unmanned vehicle, and in both the cases it's the same. There is like a very gray area, like the drones are totally military based, and multi-rotors are more like a toy or hobby grade or like slightly more professional. But when they combine together, there is like some sort of gray area, which is where you cannot define, is it a drone or a multi-rotor? Let's move on to the types of drones because there are different categories where you can like categorize the drones itself. So one would be based on sizes. We have seen this in our previous video. There are micro, nano, micro, small, medium, large based on their weight of the drone itself. And there is a payload capacity, meaning what is the drone's capability to pick a payload apart from its own weight. It could be like lightweight, it could be middleweight, or a heavy lift drones. And there is like power sources. It's categorized based on different power sources it uses, like the energy required for the drone. It could be like a battery powered, like a lithium ion or lithium polymer batteries, or it could be a gasoline powered. There's also a solar powered drones. And the next is the range. It could be like, short range, mid range, long range, depending on the battery time it holds, like the total flight time. It could take like 2 hours, 3 hours, or like 20 hours for a long range. And for a short range, it could be like 40 minutes or like 45 minutes or less than like 1 hour and so on. The next is the based on abilities. What is it capable of doing? There are drones categorized as toy grade, which doesn't have like any camera or maybe like a very low resolution camera. And it doesn't have like too many sensors. It could just be flown indoors. And there is like slightly better version, which is like professional photography and videography drones, which are capable of taking like really good high resolution pictures and videos, and it has like required sensors and so on. And there is like high level professional drones where you can like put a DSLR camera mounted on the drone, or you can add like a thermal camera, thermal imaging, and so on. And the next is like the based on wing types. This is a category is where like you can actually visually see the drone and categorize, yes, this is this specific type of drone. But rest of these, like the size, payload, the range, ability, is something you had to look into the specification. But the wing type is something you can visually see it and categorize the drone. So I would recommend categorizing the drones with this type rather than like other categories what we have seen. But it's not right or wrong. It's just that like it's visually easier to like categorize it. So let's look into that deeply. Right. The first is the fixed wing aircraft. So as the name says, it looks like an airplane. It's in a smaller version, like a model type aircraft with a fixed wing, and the rotor is somewhat like in the front or back based on puller or pusher configuration. And it could have like a semi-autonomous or autonomous system built into it, and it can be controlled by a pilot from the ground station. The other one, like from here, whatever we are going to see is based on the multi-rotor concept. So you add like one rotor each, and then the name comes up with, the terms are defined based on how many rotor it has. So you can see here it's monocopter. So mono means one, so it has like one rotor. Bicopter, bi means two, so there are like two rotors. Tricopter, 3. Quadcopter, 4. Hexacopter, 6. Octocopter, 8. So you have all these different drones categorized based on the number of rotors. So now you see a drone and you can like guess, okay, this is a tricopter, so this is like octocopter, and so on. And there is a hybrid version of these. So from monocopter to octocopter, these are also categorized or called as VTOLs, vertical takeoff and landing. So all these aircrafts take off vertically, like a fixed wing aircraft takes off like a plane with a runway. So all these others, like the monocopter to octocopter, would all take off vertically. So those are categorized as vertical takeoff and landing. So there is a hybrid between the fixed wing and these VTOLs. So based on number of rotors on the fixed wing, so you can call it like either a quadcopter with a fixed wing, a hybrid, or like a hexacopter or an octocopter with a fixed wing. So these configurations work depending on the type of applications you're working on. Cool. So let's move on to the next one, which is the different parts required to build the drone. So you have like majority of these parts which are the bare minimum required to build a drone, for a fully functional drone. So you need like a frame, you need like a flight controller and ESCs. We'll look into what these are in the next slide. ESCs are electronic speed controllers, motors, battery to power, and a radio control system to communicate between the drone and the pilot. And video transmission system is somewhat necessary in certain cases. That is a system where you mount a camera onto the drone and you see what the drone is seeing. So you might have to like inspect something or like survey something. You may need such a system. And you can combine the radio control and the video transmission system together in a Wi-Fi or Bluetooth modules. And apart from these, if you need like a more stable platform drone, like you might have to add like more sensors, like GPS, optical flow sensors, and range finders, distance sensors. And if you're like in an environment where there are like obstacles in the environment, you might have to add like obstacle avoidance sensor also. So let's look into the each of these components and how do you like go through each of those systems. So the first you would need is a frame. So there are thousands of frames available in the market. The best one is to use like a quadcopter. You can use an analogy which I always like give to a lot of students. You can take like a chair with 4 legs. So that's the most stable platform, right? You take out one leg, with 3 legs, it's very difficult to sit. Like it would be wobbly and it won't be stable. You take another leg with 2 legs, it's close to impossible to balance, right? So it's the same way with the drones. Like monocopter, bicopter is like really hard to balance or stabilize the platform. Tricopter somewhat is stable. Now the algorithm has been better and better. So you can like stabilize bicopters and tricopters. But still, like the quadcopter is the most stable platform. Even if you have like one rotor failure, you can use like the 3 rotors for the algorithm to like understand there is a motor failure, and it can use the 3 other motors and balance and stabilize for it to like get back to its initial position. And the second part is like the flight controller. So there are different flight controllers available in the market. So depending on the type of flight controller, you might have to do the wiring and the programming, the firmware, it would all be different. So you might have to choose based on that. The next is the electronic speed controllers, or ESCs. So you can basically understand this as a board which controls the motors. So if there are like 4 motors, you need like 4 controllers. The one you're seeing here is a 4-in-1 ESC. So it has like 4 controllers in a single board and controls all these 4 motors. And you can also use a PDB, a power distribution board, alongside with 4 individual ESCs and connect to the motors. So in this way, if one of the individual ESCs fail, you just have to replace just that one. But in this case of 4-in-1 ESCs, if one ESC fails, you might have to replace the entire board. The advantage with the 4-in-1 ESC is that it takes less space and less wiring, and you don't have to worry about like too much of soldering. And with the individual ESCs, you have to individually solder each of these wires to the motors and to the PDB. But the advantage is that like if one of the ESCs fail, you just have to replace that one. And then you would need a propeller to connect to the motors. And the combination of the motors and propeller depends on what sort of motors you're using. Different size motors use different size propellers. So you might have to look into the data sheet and like figure out like what size of propellers work. And next is the radio controller. This is the one which is held by the pilot in the ground and communicates to the drone. How do they do it? That's where you need to add a receiver module into this system. So the receiver module binds with the controller, and once in the initial stage you might have to do the binding, and once you're done and you power off, you can like connect back and forth without doing the binding process. So the binding is only for the first time when you're connecting the receiver and the transmitter together. So all these are powered by a battery. So that's something, depending on your type of drones, you could use like a lithium polymer, lithium ion, nickel, cadmium, and so on. Or you can also use like gasoline powered or solar powered, depending on your type of applications. So these are the bare minimum components needed to build the drone and put it together to make it fly. But if you want to like make it better, you had to like add a lot of sensors, a lot of other systems, and so on. I'll just leave this over here. This is like too complicated. You can pause this video. I'll also add like the links to the image in the description. You can look into it. So there are different components, but majority of the components what we discussed are going to be here. There are like gimbals, there are video transmitters over here, there are like multiple GPS units for you know, if there is a failure, you need to add like a redundant system. And yeah, like pretty much most of the components are covered. It depends on the type of your system you need to like add in. Let's move on to the next one, where we talk about like the different applications of drones. So there's like tons of applications coming up each and every day. We are seeing it. So the majority of the applications where the drones are being used is like aerial photography and filming. There's like survey, inspection, mapping, agriculture, search and rescue. Drone deliveries is a thing now. So there is like from warehouse to warehouse, there's drone deliveries, or from warehouse to the last mile location. You can also, there are like companies working on drone deliveries. So what exactly is Agam Robotics working on? Like, you've been watching the previous videos, or if you're new, I would recommend watching the previous videos to like see what I've been developing and designing. What exactly is Agam Robotics working on? So the idea is to like build a drone which is like in a nano size category drone, so that like users or pilots don't need to register the drone. And the payload capacity is somewhat like a less than 100 grams, because it's a nano category drone and we don't want to reduce the flight time. So it's like a featherweight category with a power source like a lithium polymer or lithium ion, with a drone range like very close range, with the ability is more like targeted towards like photography and videography, and it's not like a toy grade drone, but it's also not like a really professional drone where you know, like you add like a DSLR camera, or like the quality of a DSLR camera is not what you're expecting. It's more about like taking a quick photo or like a video shot of like a location or some place or event, and then like you quickly want to upload into a social media, and probably like, you know, with a good image quality, like not very cheap low resolution camera, more towards like a 4K camera is what we are like working towards, with a wing type of quadcopter, because that's the stable platform and it has like 4 rotors to like balance out, and there's like tons of platforms available to build towards that. But before like we end, I just want to say that like we are not just working on the drone, we are also working on individual components like the ones we saw here, like, you know, the flight controllers, ESCs. ESCs is something like I'm working on. There are like different sensors we are working on. We are also working on the GPS systems. So we also want to like individually cater to the users who are like buying these components and like putting the drone together themselves and not wanting to buy the entire drone. So we are like doing all of those together, like in parallel with the building of the entire drone. All right. Thanks for watching. If you have any questions, comment down below. If you want to like discuss about the drone applications or something, you can follow me on social media, either on Twitter or on LinkedIn. Please do let me know in your comments below. Thanks for watching.